All right, similar triangles. You guys can go ahead and label your diagram. Go ahead and label with all the givens there. Go ahead. All right, first thing notice, we gotta explain why are those triangles, how do I know those triangles are similar? All right, review, what's the main way of proving triangles similar? Everybody know, there's 5 ways to prove triangles congruent. Main way of proving triangles similar? Angle, angle, thank you, Spence, good, angle, angle. Everyone sees I have one pair of angles. Where's the other pair of angles though? I see the given pair, H congruent to RDO. Where's the other pair? Anna, go ahead. R is shared by both triangles. So does everyone see by angle, angle, both the smaller one and the bigger one are similar? Now, because they're similar, that means their corresponding sides are in the same ratio. Okay, bless you. So because the triangles are similar, we're going to set up a ratio right now. Their sides are in a ratio. So here's what I want you to do. Give me one full side, full, no partial sides in your proportions, no partial sides, full sides only. Somebody give me a full side that you know the length of in one of those triangles. I don't care. 10, one full side. HR, which is how long? How long is it? 10. Yep. All right. So we could start there. I could have started with any full side. So, but now what I got to figure out is, what does HR match up with in the smaller triangle? Okay, what does HR 10 match up with in the smaller triangle? That's what we have to figure out. Because that's what I'm going to put underneath 10. What HR would match up with in the smaller triangle. The 6 or the 4 here. And be careful, it's tough. Everybody think they know what it matches up with? What 10 matches up with? DO. It is what? DO. DO, but I don't have a length of that, though. That's the problem. It's probably going to be something that matches up when I have a length of. All right, now, take a look here. Here, let me give you, it's tough, I know, to visualize this. I get it. I struggle, too, with this. This is how I approach where do these sides match up. Do you take a look at the big triangle, everyone? Does everyone see HR is in between my 2 congruent angles? Everyone see that? It's in between H and R. So it should match up with the side in between the other 2 congruent angles in the smaller triangle. All right, that's the way it works. All right, so I see HR is in between my 2 congruent angles. So I look for the side in between the 2 congruent angles in the smaller triangle. And what's that size? 4. Okay, so use your angles to your advantage to where they're positioned in the sides. All right, what's the other side in the big triangle? Be careful here. Iris already gave me 10. What's the other side in the big triangle? How long is that side? Be careful. Got to put together a few things. 11. Yep. 1. Anna, how long is the other side in the triangle? 4x. Be careful. Is that how I put sides together? Multiply them? Oh, 4 plus x. Yep. So x plus 4. And notice, if you're still confused, what does x plus 4 match up with in the smaller triangle? Look, it's x plus 4 is across from that angle. So it should be, the side that matches up with it should be across from that congruent angle in the smaller triangle, 6. All right, so that's how you can match up your sides. Find the angles they're across from. Go ahead, cross multiply. And everyone getting 11 out? X equals 11. Next up, AC is parallel to DE. AD is 24, DB is 12, DE is 4. What's the length of AC? Okay, hey, couple weeks here, you're on your own. Nowhere in the problem does it say similar triangles. You have to recognize that this is a similar triangles problem. All right, how do I recognize that? See how they gave me parallel lines. Can anybody find any pairs of congruent angles in this diagram now? Whether using the parallel lines or something else, can you find a pair of angles for me that are congruent? Because I want to show you why they're similar and this becomes a similar triangles proof. Anybody see a pair of angles here? Eliona, go ahead. B, good. They both share B, so there's one pair. Now you guys got to use the parallel lines. Anybody remember what these were called here? This was going way back, like angle A and angle EDB. Those were called, come on, corresponding angles, and they're congruent. So does everybody see angle? Triangles are similar. That means I can set up a proportion with their sides. That's big for me. That's big. I want to make sure you guys realize why they're similar. Because it's probably not going to say that in the problem. All right, full sides only. Full sides only. Give me a full side, one of those triangles to start us off. 5. AB is 36. What does AB match up with in the smaller triangle? AB matches up with what side? 13. AB and in the smaller triangle, what would AB match up with this? Which is 12. And then from here, X, because it's in the bigger triangle, over 4. And you guys have 12. Again, just making sure we know why they're similar, and then you guys set up a proportion. All right, a couple others here with similar triangles. All right, number 3, I'm telling you they're similar. Which measurements would say they're similar as well? Okay, so given these measurements, which one of these 4 would make them similar? Real quick, and then I'll show you why it's wrong, and then you guys can pick the right one. If AD is 3, AB is 6, AE is 4, and AC is 12. I'm going to tell you that's wrong. And we're going to talk about why there's no way those triangles could be similar with those measurements. And why not? 3 corresponds with 6, and 4 corresponds with 12, but those are not equal, right? You can reduce them 1/2 does not equal 1/3. All right, so their sides have to be in the same ratio. So that is why number 1 is incorrect. All right, those sides are not in the same ratio. So find the pairs that make them into the same ratio. Three of them, they're not in the same ratio. One of them, they are. Everybody find it? Go ahead, Iris. 4, yep. 2 over 6 equals 5 over 15. 1/3, 1/3. Good work. We mentioned angle is the main way. If we were doing a proving triangles similar, I'd use angle definitely, but there are 2 other methods. All right, and one of them is side similarity, where the sides are in proportion and the angle in between is congruent. So that's what I'm looking for here. It's a question just like number 3, but now I want to use side. All right, so 6 and 8 on one triangle. What other facts would be true to make it a side proof? Can we eliminate just 2 of them right away and save ourselves some headaches? Which 2 can I eliminate right away? I don't even care what the numbers are on the sides. Just based on the angles they gave me, it can't be side. Anybody see the 2 I'm eliminating right away? Yeah? Yeah, if C and F are congruent, C's not even between 6 and 8 they give me. So there's no way it could be 3 and 4 if I'm going to use side. So out of 1 and 2 right now, which ones give me sides that are in the same ratio? Everybody find them out of 1 and 2? Which ones are the sides? I'll call on somebody here. Which ones give me the sides? 13, Charlie. 1. Yep. 6 over 9 equals 8 over 12. Done. Good work. All right. We all right? All right. Again, you guys see we're doing a lot of these because this is a huge one. If I had to rank, I'd do a top 3. This would be in there somewhere of topics that are asked every year. The amount of topics asked every year. Similar triangles would be in my top 3. All right, which one cannot be proven similar out of these 4? So let's go through each one, yes or no, and why. Number 1, do we think we can prove those similar? You got, let's review angle. We just went over side. And anybody remember the third one? Side. All the sides are in the same ratio. So those are the 3 methods of proving triangles similar. Is one of those methods in choice 1? Yeah, side, right? 3 over 9 equals 4 over 13, and they have the right angles in between. So those are similar. We're looking for the ones that are not. How about 2? 2 similar or no? Yep, by angle. How about 3? Even if 2 over 16 and I don't even think 2 over 16 and 8 over 32 are in the same ratio, the angles aren't even in between, right? So I don't even give it a shot. Why is number 4 similar? Side. And also, too, not only are these triangles similar, but they're also congruent by the regular side. So if 2 triangles are congruent, they're similar. All right. Crappy similar sign. There we go. Even worse. All right, so remember that. If you can prove 2 triangles congruent, they're also similar. All right, what do you think about 6? Go ahead and read through 6. Do you think those are similar to each other based on the givens? Kind of like a mini proof here. I don't want you to set up statements, reasons, but it's kind of like a proof. Similar to each other? Yeah. Because when you set it up, 9/6 equals the same thing as 21/14. And the angles are in between. So triangle RST, similar to XYZ by side angle side similarity. And just make sure you show that, hey, 6/9 equals 14/21. They are in the same ratio. All right, all good. They're similar triangles. You're going to see a slew of them on the exam, guaranteed. Last topic here today, dilations, dilating a line. So here's line L, 3x minus y equals 4. We're going to dilate it by 2. What's the equation of the new line? First thing we want to make a note of. Dilated lines are parallel to each other. Why is that so important? What's going to stay the same then if a line's dilated? Talked about it a couple days ago. Slopes are going to stay the same. Right? Dilated lines are parallel to each other. Slopes remain the same. So 3x minus y equals 4. Go ahead, solve. Remember, you can't tell me the slope unless it's in y equals form. What's the first step here to get it into y equals form? We've gone over a couple of these now. Nate, too? First step to get into y equals form. I want to get y by itself. Got to move a couple things over.
Subtract 3x.
All right, let's move it over. Negative y equals negative 3x plus 4. Still not by itself. What do I still need to do? 4. Still not by itself. What do I still have to do with that y?
You gotta get rid of the negative.
I do have to get rid of it. Yeah. How?
Multiply by -1.
Good. Or divide by -1. Either one's going to get the job done, right? (3x minus 4). Right? 3x minus 4. So what's the slope of this line then? 6. Slope of this line? 3. Yep. So the slope of my dilated line will be 3. Only thing I'm missing, what's the y-intercept? And this becomes pretty easy now. Make sure you circle this part right here, or underline it. Centered at the origin. All right? That's huge, because if anything is centered at the origin, you can multiply by your scale factor. Only if it's centered at the origin, though, which usually most of them are. All right, if it's anything is centered at the origin and we're doing a dilation, you can multiply by the scale factor. Watch. What was my y-intercept on the original line, L? What was my y-intercept here? We know what the slope is. 13, Charlie, what's my y-intercept? -4. So if you want to find the new y-intercept on the dilated line, I can take -4 and multiply it by my scale factor of 2. So there is my new y-intercept. Okay? So if it's centered at the origin, you can multiply by the scale factor. So my line here, y equals 3x minus 8. There we go. Dilated lines remain parallel. If it's centered at the origin, you can multiply by the scale factor. What do you got, Abby? Go ahead.
I was just wondering. Oh, actually, never mind.
You sure?
I thought that negative 3x plus 4 was a -4, and then it switched to a +4. But...
Right, it was positive 4 here, so I kept it, but then I divided by a -1, though. So that changed the sign. Right? 4 divided by a -1 gives me -4. Okay? All right, same thing here. What's the equation of this line dilated? A scale factor of 3/4. And don't overlook it. Centered at the origin. So the two things that run through my mind, it remains parallel. Slopes are equal. So the slope here, 3/2. Slope of my dilated line, also 3/2. Now you need the y-intercept. Perfect. Take the old one and multiply by the scale factor. So -4 was the old one times the scale factor 3/4. So the new y-intercept, -1, 3/2 x, not -1, geez, if I could do this correctly, maybe. How about -3? Better? Choice 4. These little facts here. Dilated lines remain parallel. If it's centered at the origin, we can multiply by the scale factor. All right, 12. I'm going to dilate triangle ABC by a scale factor of 3. Which statement's true? What does not change when you dilate? Obviously, the sides change. They get bigger or smaller, but what does not change? What remains congruent to each other? Angles, right? So automatically, I can tell you 3 and 4 are not true because it's saying the angles get 3 times bigger. Baloney, they remain congruent when they get dilated. All right, so which one is the correct one out of 1 and 2? I know I'm getting 3 times bigger. Which one is getting 3 times bigger, though? Out of 1 and 2 there, which one's correct? What are you multiplying by 3? The original, right? The original is getting dilated by 3. So that's why it's going to be choice 2. It's saying 3 times BC versus number 1 is saying 3 times the dilated. Now I'm getting even bigger. All right, now I'm getting 9 times bigger. All right, I don't want to waste time here. Let's keep going. We're on 13, right? Okay, what's the ratio of BE to CD? ABE is the image of ACD after a dilation in the origin. And here are your coordinates. What's the ratio of BE to CD? Now, could I bust out distance formula and do a ratio out of that? Sure, but if they're being dilated here, if they're being dilated, the triangles are similar. All right, if you do because the angles remain congruent. All right, so if you see you're doing a dilation with triangles, the triangles are similar to each other, which means their sides are in the same ratio. So if we're going to find BE to CD, that's going to be in the same ratio as, give me another 2 pair of corresponding sides. That'll be in the same ratio as, just give me another pair of corresponding sides now. 5. BE over CD will be in the same ratio as whole sides from the triangles.
AD.
Okay. So AD would go on the bottom because that belongs to CD. Now, what's that match up with?
ED? Wait.
Oh, that's not a part of a triangle. Ready? BE and CD. See how they're sides of 2 distinct triangles?
Yeah.
All right. Give me another pair. AE over AD, right? Or I could say AB over AC. They're all in the same ratio because they're similar. Can you guys find the length of AE and the length of AD? And we'll have our ratio. So A to D, count them. Something I couldn't do for BE and DC, count them. Let's see, AE, 1, 2, 3, 4. And AD is what? 1, 2, 3, 4, 5, 6. Oh, 4 over 6, not an answer, but we're at this level now. I think we know, hey, I got to reduce it 2/3. And finally, 14. And then I got to have you guys take a note. at the bottom of your page here. Triangles dilated by 3, which statement is true? Well, I know which 2 are not true based on our discussion today. Anybody going to eliminate 2 of the answers based on our discussion today when something's dilated? What's definitely not true?
3 and 4.
Yeah, good job. 3 and 4, because we talked slopes stay the same because the lines remain parallel, and we talked corresponding angles are congruent, not bigger or smaller. So that's gone. So is the area 9 times or is the perimeter 9 times? If I dilate something by a scale factor of 3. Anybody remember? This was one day. If you know the side ratio, this is a couple weeks ago. If you remember the side ratio, anybody remember what ratio that's the same exact as? Sides and not the area, but the perimeters were the same. All right. So if we're multiplying by a scale factor of 3, the perimeters will be in a scale factor of 3 as well. All right. Not by 9. But why is 1 true? Anybody remember how we adjusted this? Because this is not true. They're not equal to the areas. How do I do that? Get from sides to areas. I'm going to come over there and roundhouse you, Spence, if you don't wake up. How do I make them equal to each other? Come on. How do I make them equal? Square them, yeah. So if I square 3, that's why the area is 9 times. All right. Perimeter and sides are always in the same ratio. Okay, make a note at the bottom of your page because I didn't put any of these in, but you're going to see some of these tonight. Remember we talked about if it's centered at the origin, you can multiply. Well, it might be centered somewhere else. And I don't know if we remember this or not. So if the center of dilation is on the original line, so it's not the origin, so I can't multiply. It's literally on the line I'm dilating. Anybody remember what happened? The new line? Eliona, go. Perfect. Okay, it's the same line. All right, so if the center of dilation happens to be on your original line, the image is the same line. Doesn't do a darn thing. The image is the same line. So notice where the center is of dilation. You can multiply if it's the origin. If not, it's probably going to be the same line. All right, get working. Go ahead, get going.